Alright guys, so we're going to go over the first practice quiz for 15. Number 1 says, what is the point of discontinuity? A point of discontinuity could be like a hole or an asymptote. Since it's asking specifically for a point, odds are it's going to be a hole. So first step is usually to factor everything. Oops, I forgot. But in this case, it's already factored, so they already did step 1 for us. So step 2, cancel what you can. I'm going to go ahead and I notice there's an x plus 6 and an x plus 6. Those cancels out. And we're left with x plus 3. To get the actual point, step 3 is going to be take cancel and set it equal to 0. So we canceled out x plus 6. So I'm going to take x plus 6 and I'm going to set it equal to 0. And I solve for x. So my point of discontinuity, my x is negative 6. Right? Now to get the next step, take x, plug in to your simplified form. So we canceled in the simplified form was x plus 3. So I'm going to take negative 6 and I'm going to plug it in for all of my x's in the simplified form. So here I'll get negative 6 plus 3. And it ends up being negative 3. So our y value is negative 3. So the point of discontinuity, the whole is at negative 6, negative 3. Explain your answer. You could just say, because we canceled out and we have no more asymptotes, just a hole. So that's the first question. Second question is the graphing one. Right? It says graph the following function above. Remember to graph our asymptotes. So if you look on Blackboard, you will see we've posted a toolbox to help you study. No, you cannot use this on the quiz, but this is a great tool for your must-dos and a way to study. So this is what they ask for. These are the steps you can do if you want to do it by calculator, by Desmos, or by hand. Some of them only have the by hand option. So let's go ahead. I'm going to use this toolbox to help with the next problem. So I'm going to start and say use toolbox as like a side note for myself on Blackboard. There we go. Vision was blurring up. Alright, so if we want to find the 0, aka x-intercept, aka root, aka what else? There's 4 terms. Aka 0, aka x-intercept, aka root, and aka, yeah, those are it. I'm pretty sure I'm missing one, but that's okay. So if we're looking for a 0, the x-intercept, we can do it by calculator, we can put it in Desmos, look where they cross, or by hand, set y equals 0, solve for x. I'm going to add another one. Set top equal to 0, solve. So for this one, I'm going to take the top of our fraction, 4, set it equal to 0, and solve. But there's no x to solve for, which means that's not true. So there's no x-intercept, none. So for that, set top equal to 0. So that was the step for the 0 function. Next up is the y-intercept. So let's look back at our toolbox. We have the y-intercept. We can do it by calculator, you can do it by Desmos, or you could do it by hand. I'm going to do it by hand. Set all the x's equal to 0, and then just go ahead and solve. So I'm going to take my function. So originally it was 4 over x minus 5. And anywhere there's an x, I'm putting a 0 in. So we get 4 over negative 5. That's our y-intercept at 0 -4/5. And if you want, you can make that into a decimal. We do not specify, so it does not matter. But 4/5 is about 0.8. That's a little less than 1. I'm going to go ahead and I'm actually going to mark that right there. Oops, that's negative. Dang it. So just ignore that. And it's going to be this one. I don't have any white out, so sorry. So cross that one out. Oh well. We all made mistakes, but I caught it. So we're all good. So to find the y-intercept, we set x is equal to 0 and we solved. Next question is our vertical asymptote. And vertical asymptote you've been doing since section 14. And if you forgot, again, look at the toolbox. Vertical asymptote. Can only do it by hand. You set the denominator equal to 0 and then you solve for x. You might have to factor. Just depends on our situation. So I'm going to switch over to green. Say vertical asymptote, set the bottom or your denominator equal to 0. Might have to factor. Might factor. So if I look here, x minus 5, it's already in factored form. So lucky us, we don't need to do it at steps. So I'm just going to take the denominator, set it equal to 0 and solve. So add 5 on both sides. We get x equals 5. So x equals 5 is our vertical asymptote. I'm going to go ahead and I'm going to graph that. 1, 2, 3, 4, 5. And asymptotes are always dotted lines because those are just guidelines. There are barriers. We don't actually touch it or cross it. Next up is the horizontal asymptote. And the horizontal asymptote, we refer to the toolbox or your notes where we have those charts. Right? The horizontal asymptote, you have 4 options. You look at the larger degree from top and bottom. So I'm going to go ahead, I'm going to look at our graph, picture here, and our highest degree on top. There's no variable on top, which means the degree is just 0 on top. Look at the highest degree on the bottom, it's a 1. So 1 is bigger than 0, so this is bottom heavy. So when you are bottom heavy, bigger on bottom, it's 0. Bobo. Bigger on bottom, 0. So y equals 0 is our automatic horizontal asymptote. So y equals 0, and I'm going to go ahead and put that on our graph. Again, it's a dashed line. Then if you want to get the rest of your picture, look at degrees. Sorry, I didn't write that down. On top and bottom. Last, you got to figure out where your picture is going to be. So that is put in Calc or Desmos. And then just copy your general shape. So I'm going to go ahead and I'm going to use Desmos. If I can pull it up. We're going to use Desmos. I'm going to hit the divide. Oops, I need y equals. So y equals the fraction bar, 4 over our x plus 5. X plus 5. So there is our shape. Oops, it's x minus 5. That's why it didn't go. There we go. So notice how at 5, even if we zoom out, I'm zooming out, you'll never cross that vertical asymptote, and we never touch the 0. So there's our shape. So we go super, super close on this end, and we go super, super, super close through the y-intercept we had on that point. And we get very close to our x-intercept, but we don't touch it. So make sure you never cross it or touch it when you do these problems. Next question talks about 15.2. So that's all the direct variation and everything. So we're going to test what kind of variation it is. So our method is first try inverse. If it's an inverse function, then k is going to be y times x. So I'm going to go ahead and try that for the first one. I'm going to make my new table. Alright, Juju's making some noise, but that's okay. So I'm going to multiply. 4 times 80 is 320. 40 times 2, though, is 80. So they're different. So it's not an inverse. Next, I'm going to try to see if it's direct. And direct is when you do k equals y divided by x. Right? So 80 divided by 4 is 20. 40 divided by 2 is 20. 60 divided by 3 is 20. It's looking good so far, but they all have to match. 20 divided by 1 is 20. So in this case, all of the k's were 20, which is what we want, and it worked with the direct formula. So this is a direct variation. The other two are simple, just look at it. It's y equals 6 times x. So it's multiplication, which means it's automatically direct. The next one is division. It's just 15 over b. So division means inverse. And we're done. So the only one you can actually try to do work with is the direct, the table. Okay. Last problem well, second to last, because you can get an SOL question. But that's not on the first one. We're going to read this sentence by sentence. So read sentence by sentence, and we're going to put it into math. So the volume of a container varies jointly. That means V equals K with the square of its radius, which means it's R squared, and the height, which is H. So that was step 1. Right? Equation with all variables. Right. Next step, plug in and solve for K. You're always going to have to solve for K first. The container has a height of 24 centimeters and a radius of 2 and a volume of 280. So I'm going to go ahead and I'm going to plug those in. So I know it's 280 equals K because I don't know K. R is 2, but you have to square it. And H was 24. So if I can grab my calculator, do some math. Oh wait, I don't have that. Look, it's Juju. Yay. Anyway, so we're going to 2 times 2. Oops. 2 times 2 is 2 squared. That's 4. Times our 24 is 96. So right now we have 96K equals 280. And I'm going to divide it by 96. So 280 divided by 96 to get our K. So K is about 2.92. I would usually round to 2. Okay. Next step, write your new equation with K. Right, because now we know what K is. So now I have V equals 2.92 R squared H. Step 4, plug in new numbers and solve for whatever they want you to solve for. So in this case, they say what is the volume? So we don't know the volume. When the radius is 5 and the height is 2. I'm going to go ahead and plug those in. So we don't know the volume. We know K is 2.92. We square our R, which is 5, and a height of 2. So again, take out the calculator, do 2.92 times 5 times 5 is 25 times 2. We get about 145.83 centimeters cubed, because we don't forget our units. All right. That wraps up the very first practice quiz. Make sure you do the SOL review question on this unit. It's all about factoring, which you've done in Algebra 1, you've done in Geometry, you've done since quarter 1 for us, so definitely practice, practice, practice. Factoring doesn't go away. I'm sorry. All right, so here's the first video. Make sure you try and do the second one on your own, then just look at the answer key that will be posted on Blackboard. Okay, have a great day, guys.